Hello everyone, my name is Joe Scorson, channel is called Ethernet and in today's video we're going to be going over episode 15 of the Quant Finance Advent of Code. Double up today because I missed that one the other day, but it's okay, we're here now. We're here now, and you would have gotten the news as soon as I knew. If you followed my ex, you would know as soon as I knew I wouldn't have been able to get to the video that I would have doubled up on one today. I also did post a community post on YouTube just because I felt like I owed it to you guys. But yeah, that's my X account. If you'd like to actively trade my algorithm with Luxago, might be a good addition for you. There's a link in the description where you can learn more details and subscribe if you think it'd be something for you. Now, let's hop into our code. Because in this episode, we're going to be building on the parallel backtester once again. We're going to add to last episode's code by adding an option to stress test a portfolio, do it by making the price action more volatile, or by having a crash, i.e. black swans. Run both one after another. So let's hop into the main first, see what we're doing here. So right off the bat, we can just see that there are just different parameters, right? Let's actually head into the functions that we can actually see how it's happening. So we have the stress test, a stress factor, a crash factor, a recovery factor, and a method to stress test it by. So these are all needed to be passed into the run portfolio backtest function, method, whatever. I thought they were functions in Python. I guess they're methods. Look at that, you learn something new. Regardless, this is the method where we get the stock data and apply our strategy to it. So now if we want to stress test it, which is a Boolean, default is false. That way, if you don't want to give it all the parameters, just have a regular backtest, you don't have to. So just always having default values could be good in that context. So now if we do want to stress test it, then we're going to apply a stress test with whatever factor or whatever method we want and with the provided factors. So if we, and this should be a 15 just to be consistent with everything else. If we head over to the apply stress test method, now let's go over like the key differences, because this is really the different thing. I think that at this point in the series, you guys aren't that baffled by just changing around some parameters and yeah, adding different things to different function calls. So let's check out what we're doing here. So if the method is the volatility, we're pretty much just going to make every price move bigger. We're just going to make every return bigger and then recalculate the prices based on the modified daily returns, right? Because this is a percentage. So we're just going to make our percentage returns huger and then recalculate the closes based on the percentage returns. It would be crazy because stops would get hit quicker, or take profits could get hit quicker, right? We're going to go over overfit and underfit strategies. An overfit strategy would really shit the bucket when you do something like apply a stress test to it. And a underfit or properly fit strategy should just look like another day in the office. And we're going to go over that. If the method is to crash, then we're going to choose a random point. I did the seed so that way it's replicable for everybody. Choose that point randomly, and then at that point, multiply it by 1 minus stress factor, right? So here we have a 15% crash. Not really a crash, but whatever. So we're going to just drop it by that amount, and then assume that we have a constant recovery over the next 5 days, right? So we're going to drop it, and then we're going to slowly, this way, we're slowly going to increase it by 1% as we keep going to kind of simulate a dip and then slow recovery over 5 days. And then it'll just go back to normal. So then just drop our NAs, recalculate the daily returns based on those modified closes, right? So we're going backwards, 2 different methods. This is just a pen. I like to fidget. But yeah, then we're just going to drop our NAs and return our stress data. So now let's see if any of our strategies are over or under fit. If you guys remember, in the main, we're going to run it without a stress test, it with the volatility stress test, and then it with the crash stress test. So yeah. Just going to wait for that first one so we can take a look. There it goes. I'm going to move my face so that way you guys can see the end of the returns. And also just going to take this, I'll leave it in full screen. We'll see how it goes. Yeah, I don't want to like start going over it because then that'll happen, right? I don't want to start talking about them and then just get cut off. So we're going to wait for a second. Shouldn't be too much longer. There we go. So let's take a look. So now these two, I'm going to get this out full screen just so I can click between them. These two are the non-stress test results. So an 85% return and a 67% return. These two are the results with the volatility stress test. So you'll notice that the higher return really struggled with the stress test. And the lower return, it actually performed way better. It actually did better with these increased volatility. And also when we get into the crash, right, we have this dip right here. Still does fine, but it pretty much just exacerbates that drawdown. And the other one actually, again, does better, right, because it was just able to handle the crash right there. It was probably able to not be in a position, and then right here just kind of captured this recovery, right? Overfit and underfit strategies is, I think, one of the worst things to plague quantitative analysis, data analysis in any sort of aspect, right? Because these things where we fix a window to 20, you got to make sure that you do it in a way like this, so that way changes in your input don't affect your output that much, right? That's a good rule of thumb. Is if you're developing models and you want to test it out, you want to change something, and you do, and then you change a little thing and your output is massively different, go into cryptography, right? Don't use that as a trading strategy. You'll know that you make a good model when you start tweaking your inputs, you start tweaking your data, and it doesn't really affect the results that much. That is a good model. That is what you want to take to people. That's what you want to sell to people. Wink, wink. But yeah, that's something we should always have in our mind as quantitative analysts, as model developers, is that, yeah, this is a great portfolio, even with different weights and stuff like that, but how susceptible is it to changes in market condition, right? I'd rather have the 67% return and know that in the event of just ridiculous volatility or in a black swan, it'll be better able to handle it. Different people have different risk appetites. I'm the kind of person that I want to know exactly what is going on with my money, right? Even if it's depreciating, I just want to know why. Because if it makes sense why you're invested in it, then screw it. You know, I could hold the bag, right? If it makes sense. But if you're just in something, whatever happens, it should go up, right? Should it? Should it? You know, that's something we should always think about as model developers, is how overfit is our model? How sensitive is it to new information? It should not be very sensitive to it at all. It should always be able to skew itself out to have a good outcome. So just to recap, the only differences is just more parameters, and then our apply stress test method, where we have volatility or a crash to then model different black swans or different extremely volatile scenarios. So that's all I have for you guys for today. That's all I have for this video, quick one. I like these ones the most, where I just have to add one method and we're good. But yeah, I hope that you guys enjoyed that video. I hope that you guys enjoying this series. I'm going to put this on the GitHub right after. That's pretty much it. Hope that you guys are enjoying it all. Hope that it's interesting. We're going to get into machine learning pretty soon. We're not going to use any libraries. We might use something like SciPy or NumPy, of course, but now we're writing the neural network from scratch. You can do it. I promise you can do it. The backpropagation isn't that hard. I promise you'll do it. It's going to be fine. Maybe not do k-means from scratch just because I'm not that familiar with it. Maybe that's the reason we should. Regardless, though, we're going to get into everything pretty dang soon, even if I end up having to change up the roadmap just so it's something a bit easier to input from scratch. Like doing an LSTM model from scratch, like, come on. They're also not that great for stock prediction if anybody's ever used them. So might change up the roadmap a little bit. But yeah, I want it to be a lot of stuff done from scratch, like Garch, right? Or the Hurst exponent, like Garch. Like, I think that doing it like this, where you make your actual function with the parameters and you can just minimize the negative one. I'm not showing you guys my code. I think that doing it like this, I think this is so cool. I think this is sweet. This gets me giddy, right? Yeah, this is what gets me inspired. This is what makes me want to code. This is what makes me want to be a better mathematician and engineer. Yeah, regardless though, hope that you guys enjoyed this video. Links to everything will be in the description, and I hope I'll see you guys in the next one. Peace out.